Hi, good morning. Okay, now I will start. This is the topic from the chapter about elasticity. Then we are going to talk about like elasticity and how really materials they respond to stresses. Then this is about elasticity. All right, when we talk about elasticity, we are going to use a new material, like a new vocabulary, like stress and strain. The first time I'm gonna, you know, talk about. Now, stress will cause a strain, and the strain might lead to what is called elastic deformation. That deformation, it can be change in length, it can be change in area, it can be change in volume. The first thing to describe is stress. It is defined as force per unit length, per unit area, sorry. And therefore, it is F divided by area. Now, that is the unit. It is in Newton per square meter, or we call this pascals. Now, I will say before we start actually talking more, okay, we want to be very specific. Then we're going to talk about the stress that is resulting from tension, tensile, and the one that is resulting from compression. We call it compressive stress. And we are going to study what is the resulting strain. All right, then here, let's assume I have a rod that has a length that is L0, and then I start applying a force like this. This is tension. Therefore, we are going to have a stress that equals the force divided by A. A here, it is area, and it is a cross-sectional area. Then if this one, it is like a rod, then the cross-sectional area is a circle like this. If it is maybe like I would say a rectangular or a square, we're gonna find that the area is gonna be L squared or L times width. Now, as a result of this, we are going to find that the length now is gonna increase by delta L because of that. And here I will say we are going to have a resulting tensile strain, and that is delta L over L0. It's just the ratio between the change and the original length. Okay, it was studied for a long time that and proved that stress equals a constant times a strain, which means there is a direct proportionality between the two. Now that constant, when we are talking about tension, tensile, and compressive, it's gonna be called Young's modulus. We call them moduli, equal Y times strain. We can write this as F divided by A, and that is Y, and this is delta L divided by L0. Then this is the equation that I'm gonna use. Of course, as I mentioned, this is called Young's modulus. In your textbook, you're gonna find that these values are listed for different materials. For example, I will say for AL, we have Young's modulus as 0.7, 10 to the 11 Pascal. And if we move on to steel, you're gonna find the difference between the two to 10 to the 11. All right, then this is really the information, some of the information that can be provided. Of course, we treat compression the same way that we treat tension. Now, the other one, we call it, the second type, we call it shear stress, and of course, shear shear strain. Here, let's assume you have this object and you start adding forces. This is F and this is F. And let me assume that this one here, it was actually having these dimensions as this is H, and I can say that this one is this one here, when we're gonna have that deformation, this one I'm gonna call it X. Now the strain here is gonna be X divided by H. And I don't know if you notice, there is no unit here. Yeah, all the strains, they don't have a unit. Now I can create a similar equation to that, okay, F, but now it is parallel, divided by A should equal that shear modulus X divided by H. And S, we call it shear modulus. And this one, it is considered to be a distortion in the area. Now the last type here, it is about volume, stress, and volume strain. It's the same idea, but I'm gonna give you the resulting equation. Any change in volume is gonna be opposing the change in the pressure. Okay, like I forgot that constant. The constant here, we call it bulk modulus. And it is the change in the volume divided by the original volume. This is change in pressure opposes change in volume. This is why we have the negative here. All right, I'm gonna stop here for this one because this is a short section of the chapter, and I'm gonna have another video for you.